Grade 10 Mindsetters. It is a Maths Monday, and with you today is Looney and Lisa. Lisa, how are you doing?
I'm very well, thank you, and happy to be here. It's the first time that I've done grade 10 this year, so I'm very excited.
Oh, welcome then. So what are you doing for the grade 10s today?
Well, what we're going to do today is we're going to start with geometry. So we're going to have a look at some things that you should know from last year, similarity, congruence, and then we're going to move into the midpoint theorem. And next week, we'll be looking at the properties of quadrilaterals, all of those properties that you should know, and questions based on those. The students find geometry difficult.
Yeah.
So guys, you need to be really patient. And geometry is a little bit like preparing for the Olympics. You don't just do a lot of exercises the day before. It's a long-term commitment.
Yes.
So this is just the start, but keep practicing.
All right. Grade 10s, you heard it. Lisa, I'll send you to your board. Guys, don't forget to keep in contact with us on Facebook. It is facebook.com/LearnExtra. On Twitter, you can get us at our handle. It is @LearnExtra. Don't forget to download all your show notes, your schedules, and the videos on learnextra.co.za/live. Grade 10's Liesel told you everything about today's lesson and next week's, so I won't take any more time. I'll take it back to Liesel.
Right, guys, I hope that you're ready to get started. So we're going to start this lesson off by some of the things that you must know from last year. So as I said before, similarity, congruency, and the midpoint theorem, that's on our menu for today. So in this lesson, we're going to revise some of your basic geometry skills. So we're going to have a look quickly at corresponding angles, alternate angles, your basic little things about triangles that you should know, but we're going to be very quick about that because, of course, the most important thing is the midpoint theorem, which is coming later on. We're also going to start off by just having a look at what is similarity, what is congruence, and how to apply those concepts on some questions. Right, guys? So just quickly, I want to talk about some of the things that you should know from geometry in general. So we're going to pull up a blank page, and let's start with very simple angles on a straight line. This you should have known even from primary school. Angles on a straight line, or supplementary angles, add up to 180 degrees. So that's our angles on a line. Then also angles around a point. Angles around a point add up to 360 degrees. I'm not even going to write that one down. What else? Something that we're definitely going to be using in today's lesson is vertically opposite angles. Vertically opposite angles, like those, are equal. Vertically opposite angles, right. Then quickly, let's just have a look at some of the properties of parallel lines that you should know about. If we have a scenario such as this one, where I've drawn one line and another line, and I know that these two lines are parallel to each other, there are certain things that I can then have a look at. The first thing we're going to have a look at is alternate angles. Now, alternate angles, we look for the Z or the N shape. The Z or the N shape indicate alternate angles. Remember, alternate angles are equal, but only if they are between parallel lines. So these two angles over here will be equal as long as the lines are parallel. So the Z shape deals with alternate angles. Right, then there's another shape that we can look for, and the next shape that we look for is the F shape. If I have a look, let's do it over here. This is an upside down F, but this angle over here and that angle over there will be equal, once again, as long as the lines are parallel, and the reason for that is corresponding angles. And then finally, with the parallel lines, we also look for a U shape. Some people like to look at it as a C shape. And these are called our co-interior angles. Now, guys, it's very important that you remember that where corresponding and alternate angles are equal, co-interior angles are not equal. They are supplementary. In other words, they add up to 180 degrees. So if I put a little U in over here, then this angle marked with the green dot and this angle marked with the yellow star, if I add those two together, I get 180 degrees. So if this one is 80, then the star angle is 100 degrees. Right, now I think that's more or less all the pre-knowledge that we need for today's lesson. Next week, when we talk more about quadrilaterals, I'm going to talk more about the different types of triangles. So everybody should know this. You were taught this in grade 8 and in grade 9, so hopefully this won't present a problem. Now let's go back to our questions for today, or to our, there we go. Right. So the first thing that I'm going to talk to you guys about today is similarity. Guys, similar figures, and they don't have to be triangles, although we generally are going to be working with triangles. It says here that geometric figures are similar if they have the same shape but a different size. So think to yourself, for instance, if you have a picture that you photocopied, if you then take that picture and you enlarge it on the photocopy, then what will happen is the two pictures will be similar. They'll have the same shape, they'll have the same outline, but they'll have different sizes. So let's have a look specifically for triangles, what we need to do to prove that they are similar. So here are the conditions. They listed for us here. I'm going to start off and actually I think this might be a mistake, Noni. I'm going to ask you if we can perhaps quickly go to a break. I just think there might be a mistake in our notes. I just want to check it out quickly before I get anybody nervous and confused. All right.
Guys, let's take a very, very short break and then we'll be back right
after. Actually, it's not even necessary. I've figured it out. I think we've got it right. It was just a wording issue. Here we go. No, that's fine. This is congruency. Sorry, guys. The first slide is actually on congruency, not similarity. Right. So we've said now what are similar figures. Similar figures are enlargements or of one thing or another. So if you take a photocopy and you enlarge it to 110%, those two things will be similar. So that is similarity. Now let's quickly talk about congruency. Congruency is if two figures are exactly alike in every aspect. So if you have two triangles that are congruent to each other, if you take those triangles and you cut them out, it will be possible to fit the one triangle perfectly onto the other triangle, right? So similarity, it looks the same. It's like a map or something that gets increased or decreased in size, but congruency, they are exactly alike, right? So that's the difference between similarity and congruency. Now, let's have a look at what I need to prove that triangles are either similar or congruent. And we'll start with the congruency. Right. So obviously, if two triangles are congruent to each other, they are exactly alike in every aspect. Very difficult to draw them exactly alike. So the corresponding sides will be the same lengths. And the corresponding angles will be the same size. So this angle will be the same as that angle. That angle over there will be the same as that angle over there. And obviously, that one will be the same as that one. But it isn't actually necessary to prove all of those things, right? So we have got certain conditions. We've got to have at least 3 things. So the first one is side, side, side. So if I can prove that this side is the same length as that side, this side is the same length as that side, and this side is the same length as that side, I have managed to prove that the triangles are congruent. The next condition is if I can prove that 2 angles are equal and one side is equal. That's my second condition for congruency. And then finally, if I'm dealing with a right-angled triangle, I've skipped one here, so let's just quickly write them down. It's side, side, side. It's side, angle, side. It's angle, side, angle. That's 1, 2, and 3. And then the final one is right angle, hypotenuse, and side. So that is, if I have a right-angled triangle, so I'll obviously know that this angle is 90 degrees, and that angle is 90 degrees, right? If I have a right-angled triangle, then as long as I can prove that the hypotenuse and one of the other sides are equal, then I have managed to prove that the triangles are congruent. I just want to go back quickly to side, angle, side. Now, side, angle, side doesn't just mean any 2 angles. Side, angle, side doesn't just mean any 2 sides and an angle. It has to be the side, and the included angle. What do I mean by that? Let's have a look here. If I can prove that this side is equal to that side, and this side is equal to that side, then I do have to prove that the angle included into those 2 sides is equal. The only exception for that is when I use right angle, hypotenuse, side, because as you can see here, the angle isn't actually included. Right. So our conditions for congruency: side, 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 angle, and right angle, hypotenuse, side. Now, before we go on to the similarity, I think it's time that we take a quick break. You guys can digest the information on congruence, and then we'll talk about the similarity right after the break.
All right, mindset is we are going to take a real break this time. So don't go anywhere, as we'll be back doing maths and all this congruency stuff, similarity, and all of that. So stay tuned, guys. Welcome back, guys, from that very short break. I hope you guys are ready to start the lesson. Just a quick question, Lisa. Tabang is asking, what do you call a triangle which is SAS, which I'm guessing is side angle.
Okay, so the first thing, Tabang, that we need to talk about, it's not a triangle. It is 2 triangles. So we're talking about a triangle and another triangle that have an equal side, right, another equal side, and the included angle is equal. Now, these 2 triangles are congruent. That means that they are exactly the same in every respect. If you were to cut them out and put the 2 on top of each other, they will fit on top of each other perfectly. So you will call the 2 triangles congruent to each other. And the reason is side, angle, side. And just before we move on to similarity, let's just quickly talk about how you will put things out. If I have this sort of scenario, and where I've got 2 triangles, let's call this A, B, C, and D, E, F. Okay? So what I will say, let's say I'm given that that side and that side are the same, that side and that side are the same, that and that is the same. I will start off by saying, in triangle ABC and triangle DEF. And then I will start listing all the things that I know. Now, sometimes you will have to use your knowledge of geometry. Sometimes, if you're lucky, things will be given to you. Now, I'm going to say AB is equal to DE. And the reason for that is the fact that it's given. Then I'm going to say that angle B is equal to angle E. That is also given. And for the very same reason, then I'm going to say that BC equals EF. Once again, that is given. Now I'm going to say, right, that means that triangle ABC is congruent to triangle DEF. And my reason for congruency in this case is side-angle-side. So there's a couple of things that I just need to highlight. It's not the triangle that's SAS or ASA. It's two triangles that are congruent. And the reason why they are congruent is side-angle-side, or whatever the case may be. And the sign for congruence is those three horizontal parallel lines. Tabang, I hope that answers your question. So let's carry on and move on to similarity. Right. So we said before that geometric figures are similar if they are the same shape but different sizes. Now, it's very, very important that we don't get confused between congruence and similarity. The first possible reason that we can have to prove that two triangles are similar, it says here SSS, but don't confuse it with SSS from congruency. This is different. The reason is it says the three corresponding sides are in proportion. Now, what does it mean that if they are in proportion? Let's say this side is 2 units long and this side is 6 units long, right? This side over here is, let's say, 1 unit long, and this one is 3 units long. I'm just making this up. And then let's say this is 3 and this is 9. Now, these two triangles are similar because 3 of their sides are in proportion. What does that mean? 6 divided by 2 gives me an answer of 3. 3 divided by 1 gives me an answer of 3, and so does 9 divided by 3. So these triangles are clearly not congruent. If I were to cut them out, the one would definitely not fit on top of the other, right? But they look the same, and the first possible proof is to prove that 3 corresponding sides are in proportion. So the same scale factor is used, but they're not the same length. That's very important. The second possible proof for similarity, and please, if these are going to confuse you, then rather don't even look at them. Just remember the words, because to be honest, that's what confused me just now. Now, the second possible reason for similarity is if I have 2 sides that are in proportion. So let's say 3 and 6. So I can see here that 4 over 2 gives me 2, and so does 6 over 3, and then that the included angle is the same size. Then I've also managed to prove that they are similar. And then finally, the last proof, an angle, 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 you'll only ever see in similarity, is if I am able to prove that this angle is the same as that one, the top one is the same, and that one is the same, then angle, angle, angle. So rather than get confused, I would say, remember, with similarity, 3 sides in proportion, not equal, because if they're equal, then the triangle is congruent, right? So 3 sides in proportion, 2 sides in proportion, as well as the angle included, or finally, all 3 angles. Then I know that my figures are similar, and this is how you will set it out. If you want to say ABC you'll list the angles, obviously. Triangle ABC is similar to triangle DEF. Right. So the sign for similarity are 3 vertical parallel lines. The sign for congruence are 3 horizontal parallel lines. Guys, so that's similarity and congruence. Let's have a look and see if we can apply these concepts to some questions. Right. The first question asks us, state if the following is true or false. Triangle 1, that's this triangle over here, and triangle 2. And they want to know from us, are these triangles similar? Those vertical parallel lines mean similar. So because the lengths of all the sides are given, what I'm going to do is I'm going to check the first condition. I'm going to check whether their sides are in proportion. If I go 12 divided by 4, those 2 sides are clearly corresponding, then I get an answer of 3. If I go 15 divided by 5, I get an answer of 3 as well. And if I go 9 divided by 3, I'll also get an answer of 3. So the 3 sides are clearly in proportion, and that means this is absolutely true. These 2 triangles are similar to each other because their corresponding sides are in proportion. Let's have a look at the next question. All right. Now, the next question says, state if the following is true or false again, and left out here is the sign for congruency. So let's have a look. They want to know, is triangle IJK, that's this one, we'll highlight that one in yellow, and this one in pink. Now they want to know whether these 2 triangles are congruent. Right. Now, the first thing that I can say is that angle L is equal to angle J, and that's equal to 90 degrees. So I've got a 90-degree angle there. That definitely corresponds. Then it is given to me that IL, the side, is the same length as JK. So you'll write given. Now I think to myself, I'm still missing something. I've got a 90 degrees, so that's a right angle. I've got another side, and what is that reason for congruence? It's right angle hypotenuse side. And let's have a look at the hypotenuse. The hypotenuse obviously is the side across the 90-degree angle. And can you guys see that these 2 triangles actually share the hypotenuse? So IK is equal to IK, and the reason we can use here is that it's a common side. So in this case again, it is definitely true that these 2 triangles are congruent. And remember, those signs mean congruent. Right, so I'm hoping that this is helping you guys a little bit in just seeing the difference between congruence and similarity. Right. The next question says, state if the following is true or false. Triangle ABC, and we're talking about similar to triangle DEF, and then they ask us, is the scale factor 4,5? Right, now, if I look here quickly, to get from 2 to 10, I clearly have to multiply by 5. So yes, they might be similar, but the scale factor is not 4,5. If it was 4,5, so therefore this one is false. If it was 4,5, then this would have to be 9, because 2 times 4,5 gets me to 9. Right. Let's have a look if there's another one. Right, no, boys and girls, we're going to have to take a quick break. After the break, we're going to have a look at the midpoint theorem. So that's similarity and congruence. Next up is the midpoint theorem.
All right. Guys, we are going to take a very short break. Don't forget to ask me all your questions that you may have on facebook.com/learnextra and on Twitter at learnextra on Twitter. That is our handle. And guys, don't forget to download all your show notes, the schedules, and the videos. So do remember to stay tuned because we'll be back right after this. Welcome back, Mindsetters, from that break. I hope you guys are ready to continue with the questions. Just a very curious question from up here where he asked, is today's show under analytical geometry or Euclidean geometry?
Okay, well, today's show is definitely under Euclidean geometry. Remember, guys, analytical geometry is where we use the distances and gradients and midpoints. So this is definitely under Euclidean geometry.
All right, up here you're being a smarty pants over there, showing everyone that you know a little bit more about geometry. So well done to you. It is Euclidean, and we'll take it right back to
Right,
Lisa.
guys, so now we're starting with the first thing that's really a little bit new. And this is called the midpoint theorem. Right, so the midpoint theorem says the following. It says the line segment joining the midpoints of two sides of a triangle is parallel to the third side and equal to half the length of the third side. Yo. So let's first unpack, what does that mean? Well, what the theorem means is if I take this side AC and I find its midpoint, and I call that midpoint E. And I then take BC, I find that side's midpoint, and I call that midpoint D. If I then draw a connecting line to connect E and D, the following things are true. Firstly, ED is parallel to AB. All right? ED is parallel to AB. We're going to get into proving that just now. And also, ED is exactly half of the length of AB. So that means if I know that these are the midpoints that are being joined, I can safely assume that if AB is, let's say, 10 units long, then ED is 5. Right. There's other things that I then also can assume, obviously, because it proves that the lines are parallel, I can use a lot of the things that we spoke about very early on in the lesson. For instance, the corresponding angles, those angles in the F shape, will be equal. There's another corresponding angle and another corresponding angle. And the co-interior angles will add up to 180 degrees. Right. So the theorem, and that's what we're going to use, says that if I join the midpoints of two sides of a triangle together, then that new line that I've created will be parallel to the third side, right? So they'll never meet. And the new line that I have created will be half the length of the third side, right? So let's get on and have a look at how I'm going to prove this. So what I've done over here is I've basically redrawn this diagram over here, and I then have to do a construction, right? So we start off with our triangle like it looked over there, and we now make a construction, and that construction is that I'm going to extend the line ED, and I'm going to extend it in such a manner up to F. I'm going to extend it up to F so that ED is equal to DF. So let's write that down. I start with a construction. And that is to extend ED to F so that ED is the same length as DF. So that's very important. If you forget to do the construction, then the whole thing is kind of going to fall apart. So very important that we have to do that construction. Right. Now the next thing that I'm going to do is I'm going to use my knowledge of congruence, and I'm going to prove that this triangle over here, ECD, I'm going to prove that triangle ECD is congruent to this triangle over here. So let's write that down first. In triangle ECD and FBD. And please, guys, note that I'm trying to do this in the same order. Triangle FBD. FBD. Now we have to look at some information in these triangles, and we've got to prove that these two triangles are congruent to each other. Now, the first thing that leaps out at me is if I call that angle D1 and this angle D2, is that D1 and D2 are equal to each other. Why are they equal to each other? I wonder if people are asking us on the page. The reason is what we discussed earlier on. They are vertically opposite angles. So let's write that down. D1 is equal to D2. Vertically opposite. Right. Now, I know that ED is the same length as DF because I did that in my construction, right? I specifically said in my construction that I'm going to extend the line ED up to F so that those two portions of the lines are the same length. So let's write that down. ED is equal to DF, and that is construction. ED is equal to DF, and that's my construction. So I've got an angle, I've got a side, I need one more piece of information, and here's my final piece of information. Remember, we said that we are joining the midpoints of the two sides together. So if D is the midpoint of CB, then CD and DB are the same length. You can say given or midpoints, that's fine. All right. So therefore, the two triangles, triangle ECD, is congruent to triangle FBD. And I used a side, and the included angle. So that is side, angle, side. Right, so let's go back to our sketch and see what that means. Now, because of the fact that these two triangles are congruent, I now know all sorts of things. Besides for the things that I've already proven, I can also say that this side will be the same length as this side, that angle will be the same size as that angle, and that this angle will be the same size as that angle. So you'll write that out very nicely. The reason for that is congruence. Remember, you only need the side angle side, and then you can prove that all the other angles and all the other sides are equal. So, what does that now mean? Well, let's have a quick look. I've now said that this side is equal to this side. Do you guys agree? That's absolutely right. Fine. But if this side is equal to that side, it must also be equal to this side, because remember, EC and AE, or is it a B here that I've scratched? No, it is an E. They are the same length. So I can now say, out of the congruence, that one is equal to that one, but it's also equal to that one. Then, let's have a look here. Because my alternate angles are equal, look at that green dot over there and that green dot over there. Because my alternate angles are equal, I can say that this side is parallel to that side, right? Remember, alternate angles are equal only if the lines are parallel. So if I'm given that the lines are parallel, I can say, right, the alternate angles are equal. In this case, I know that the alternate angles are equal, so now I can say that the lines are parallel. So what have I managed to do here? If you have a look at this little portion over here, I'm going to rename it E, F, B, and A. Because I've proven that this side is parallel to that side, and that this side is equal to that side, I have managed to prove that this portion over here is a parallelogram. Now, what do I know about a parallelogram? I know that the opposite sides are parallel, so then I've managed to prove that ED is parallel to AB. But also, in a parallelogram, the opposite sides are equal and parallel. So I've proven that EF over here is is equal in length to AB, but ED is exactly half of EF. So I've managed to prove that that little portion is half of this line. All right, so that's quite a lot to take in. I do realize that, but let's just quickly go through what we had to do. We had to do a construction. Then we had to prove that these two triangles are congruent. Then we used the fact that they were congruent to say, all right, all the corresponding sides and angles are now equal. And out of that, I then managed to prove that this side is the same length as this side and that they're parallel. And remember that one pair of opposite sides, parallel and equal in length, is enough proof for a parallelogram. So I've managed to prove that this is a parallelogram, which obviously means that this line is parallel to that line. And because of the fact that EF and AB are equal in length, because it's a parallelogram, I've managed to prove that ED is exactly half the length of DF.
Liesl, can we take a short break?
Yes, sure.
Okay. Guys, we're going to take a very short break, but we will be back straight after this.
Thanks.
Welcome back, Mindsetters. I hope you guys enjoyed the break. I'd just like to send a quick shout out to Calvin, Apiwe, Dingani, Clemi, let me see who else, Shalanati, and everyone else who's watching, guys. Those people were the ones who are on there first and were just like, I'm enjoying the show, I'm really excited about maths and all of that. So I'm sending a shout out to all of you guys. So
they need to give us feedback as well.
Oh,
if
okay.
they got any questions,
Yeah.
Is there anything that we need to go over a little bit more carefully?
No, there was just that one question where the person was asking how you determine the sides of an unknown angle, and then it's libia leshogonolo. So if you could just please be more specific about what you're talking about, like what sides, what angles, what triangle you're talking about, and then Lisa will be able to help you.
Right, guys, yeah, that's the question. Very legitimate, but it's a bit like how long is a piece of string, so we're not really going to know. Right, guys, so what we managed to do in the previous segment is we spoke about the midpoint theorem. So we said, if you find the midpoints of two sides of a triangle and you connect those midpoints to each other, then that new line that you've created is parallel to the other side, the side that's not involved, and that new line is exactly half of the length of the third side of the triangle. Now, guys, I went through the method for the proof. You have to do the construction. You've got to prove the two triangles congruent to each other. I didn't write out the whole proof, but every textbook will have it. Work through it very, very carefully. As long as you know where to start, it shouldn't be too much of a problem. And remember, set everything out carefully. Give reasons for every statement that you make so that you don't lose unnecessary marks. Right, so now we're going to have a look at some questions where we apply some of this knowledge of the midpoint theorem. And we're going to start off quite slowly. The first question is really quite easy. Let's have a look. It says find x in the following. Now this is what's important. What you guys need to see is that this side is the same length as that side. So in other words, I have found the midpoint over there, and this side is the same length as that side. So this is the midpoint, and I've connected the midpoints of the two sides. Now, what we've just learned is that this line is parallel to that line, that's the first thing, and that it is exactly half of the length. So what I will do here is I will quite simply say x is equal to 14 units. And my reason is the midpoint theorem. Right. The midpoint theorem says that this line and that line are parallel, and that x will be twice the size of the two, twice the length of the two midpoints joined together. Right, let's have a look at another question. Now, I can see that this is going to start getting quite predictable. The first questions are easy. Once again, I've got the same scenario. I've got the midpoint of two sides joined together. So I know that that line connecting the midpoint of the two sides is exactly half the length of the third side. So if the third side is 7 units, then x must be equal to 3,5 units. And exactly the same reason once again. Looney, how are things going there? Are people following? Have we got more specific questions?
Banky on Twitter is asking, how do I know whether to write down the congruency steps or to work out the proof? So maybe he or she is asking, when asked, should he or she write down the steps of how he got to it, or must he work out and prove that?
Okay, well, you basically get two types of questions. In some questions, they ask you to prove, and other questions are numerical questions. But in each case, I will write down a statement every time, as well as a reason. But again, if we can have a slightly more specific question, then that would be a little bit easier. Now, let's just have a look at the next one. Now here, we are talking about the midpoint theorem again, but now things are getting ever so slightly more complicated. So I'm going to do this question using the midpoint theorem. Now, let's have a look quickly. We are told that that side, the entire side, is 6 units, and that this entire side is 8 units, and we are told that this angle over here is 90 degrees. Now, guys, I am then able to calculate the length of this side over here using the theorem of Pythagoras, right? I'm going to say that, let's call this side over here b. b squared is equal to 6 squared plus 8 squared. Okie dokes. And 6 squared is 36. And 8 squared is 64. So therefore, that side b over there, b squared, is 100 units, meaning obviously that b will be the square root of 100, which is 10 units. So now I can say this side, which I've highlighted over here in purple, is 10 units long. So I could have gone directly to x, I suppose, as well. If I'd said that this is 3 and that is 4, then I could have just worked out x with Pythagoras. But I wanted to really apply the midpoint theorem. So now I can say that x is equal to 5 units, and again, my reason is the midpoint theorem. Right. Let's move on to our next question. The next question says, I must calculate x and y. Right. Now, in this case, once again, we've got the midpoints, the midpoint of PS and the midpoint of PT are joined together. Now, there's two things that we know from the midpoint theorem. The first thing is that if we join the midpoints together, that new line is parallel to the third side. That's the first thing. And the other thing is the issue of the new line is half the length of the third side. So let's have a look here quickly. I'm going to start off by doing x. So we just say that x is 28 units. And the reason for that is the midpoint, because obviously x must be twice the length of QR. Now for the first time, I get a little bit into the business of finding some angles. So this gets a little bit more interesting. So I now have to find the size of angle y over here. Now it's very important that you realize from the beginning that the line QR is parallel to ST. The line QR is parallel to ST. Why is it parallel? Because of the midpoint theorem. So I'm going to put in my parallel stripes there. So you'll write down that QR is parallel to ST, and that's because of the midpoint theorem. Right. Now, I'm going to now have a look at this triangle over here, which is PQR. And I'm given that angle P is 40 degrees, that angle R is 60 degrees. So let's call this angle over there Q1. And I'm going to say Q1 is equal to 80 degrees. And we didn't go over this at the beginning of the lesson, but guys, the interior angles of a triangle add up to 180 degrees. So I'm going to use angles of triangle as my reason. So now, if this angle Q1 over here is 80 degrees, and it is true that the line QR is parallel to ST, because of the midpoint theorem, I can say that y is equal to Q1 is equal to 80 degrees. And remember earlier on we spoke about that F form over here. There we've got the F. And we said that the F form indicates to us corresponding angles. So I'm going to write down corresponding angles. And if you haven't stated it before, you do need to say that QR is parallel to ST. Right, so in this question, we've incorporated the fact that the line joining the midpoints is twice the length of the third side, and the fact that it's parallel. So we had to know that it's parallel, else we couldn't have used corresponding angles. Looney, how are we doing there time-wise? Have we still got some time left? Have we got some questions?
No, there's no time. We have to wrap up.
Oh, that's such a pity. Well, we've got one more question left, guys. I think you guys can probably see that it's much of the same thing, and you will be using the fact that the line joining the midpoints is half the length of the third side and parallel. Guys, it's been a real pleasure. Geometry is always harder to get through many questions, and it's always difficult to answer your questions, but please remember my advice that you have to practice to make perfect.
All right. Guys, you heard all of that. You have to practice in order to be perfect. I hope you guys enjoyed the show and you understood what Liesel was going through. You have to go through all your notes, guys. It's learnextra.co.za/live, and I did post the link on the Facebook page. I hope you guys enjoyed the show, and we'll see you same time, same place next week, Monday. Bye, guys.